Hi everyone, welcome to today's lesson, which is hopefully a refreshment when compared to the other complicated videos we've been watching all day. Let's talk about some math and music. So, there is a love story between math and music. They've been together for a long time, but you might be wondering why. Let's see, as we jump around in different historical times, we can find them on dates in ancient China, India, Greece, the Roman Catholic Church, and other places. As time passed, famous musicians started realizing their intimate relationship, so they acted upon it. We can see Bach, Mozart, Haydn, Beethoven, and other musicians use this cute relationship to create works of art. Now, I do realize I just jumped from a lot of different places of the world in different periods of time, but that's actually very significant because it shows that math and music are the hottest couple throughout history. And I can show that to you by the two's matchmaker, which is the Fibonacci number. The Fibonacci numbers are formed by the start by two ones and then created afterwards by adding the previous two numbers together. These numbers form a magical sense in mathematicians because of not only how often it appears in everything, but also the divine proportions it creates in something known as the golden number. Golden number, about 1.618, represents the Greek letter phi. By dividing a number in the Fibonacci sequence with the one before it, we can see that numbers draw closer to the number of 1.618. The golden section is a method of dividing something into this ratio, which becomes something around 0.618. This is a concept seen in music from all periods. Mozart used exposition, development, and recapitalization in his works and created symmetrical proportions that was seen as the golden section. In the moment where the exposition is changing to the development and recap, the measure it is at is around the proportion of 0.618. For example, in his Mozart Sonata 279, number 1, for example, out of the total number of 100 measures, 38 of them is used as the exposition and the other 62 is for the rest, putting the placement of the change at exactly 0.618. Mozart is just one of the many well-known musicians who use the golden number. Other examples include Beethoven and Debussy. Throughout history, the golden number remains a common point of time in the piece where the change is made. As we fast forward to the 20th century, we can see that most modern songs can be simplified into a four-chord song structure, usually summarized by verses, choruses, and bridge. Most of the time, the bridge is where the climax of the story of the song is at. If we perform a little calculation for where the climax is, we can see how the golden number fits into modern-day songs. The calculation goes as follows. We take the song length in seconds to make the calculation easier, and then multiply it by 0.618. If we check the time of the song to what we calculated, it should be around the climax, which proves the point of it using the golden number. Let's give an example with my favorite things from The Sound of Music. We are looking for key changes or bridges, which are considered shifts in the climax point at the golden number time. My favorite things is a song length of roughly 2 minutes and 20 seconds. That makes it 140 seconds. We multiply it by 0.618, becomes 86.52 seconds. And around that time is right at the moment where the song shifts keys, meaning that it is modulation. Modulations are used to mark shifts in the story of the song, demonstrating how this song from the classical musical used the golden number. You can actually do this for a lot of other songs as well, as you can see here. Now I hope you see the interesting relationship between the hottest and oldest couple out there. Today we learned about Fibonacci numbers, the golden number, and how that applies to music throughout history. See you next time!